All right, we're going to start chapter 11 today, and we're going to break section 1 up into two parts. The first part is we're just going to talk about solid figures. We're going to start looking at, in chapter 9, we started talking about the different shapes, the circle, the rectangle, the trapezoid, the kite. We had different figures and we had different formulas for finding the area perimeter of those. Okay, we're going to take that another step further, and we're going to start working in 3D, three-dimensional figures now. So we have solid figures. And it says solid figures are generally named according to the form of the figure and the shape of its base. And we have four different solid figures that we're going to look at. We're going to look at prisms, and we're going to look at cylinders. Okay, that's two of them. A prism has two parallel congruent polygon bases connected by lateral faces that are parallelograms. So you can see we have different prisms. Okay, prisms are going to have parallel congruent polygon bases. What does that mean? Well, the base is what it's going to sit on here. Okay, that's a rectangle that it's sitting on. So you might think of the Kleenex box. Like a Kleenex box, since that's a rectangle, we call it a rectangular prism. Okay, and it has lateral faces. So when you take, this would be a square prism. Okay, we're going to say that the base of it's probably a square. I'd have to measure that, but it looks like a square. So that would be a square prism. But when we talk about, we've got faces of it. So each side is a face. This is like a cube. Okay, how many different faces are on the cube? Well, you'd say that there's one on the top and one on the bottom. That's two. There's one on each side. That's 3 and 4. And there's one in front and back, that's 5 and 6. This rectangular prism has 6 different faces. Okay, it says the lateral faces of a prism are parallelograms. Okay, a square or a rectangle is a parallelogram. All right, we've got a different prism here. Okay, the base of it, what it's sitting on right here, that would be a hexagon. It's got a 6-sided figure, so we call that a hexagonal prism. So you're going to look at the base. What's the shape of the base? What kind of polygon is it? And it's that, and it's a prism. So you could have a pentagonal prism if it's a 5-sided base. You could have an octagonal prism. You can have a square prism. You can have a rectangular prism. Okay, the faces are parallelograms. The lateral faces are going to be parallelograms. But these would be prisms. So one of the things you're going to do on your worksheet is they're going to give you a prism, and you're going to tell me how many faces it has. Faces are the flat surfaces. You might tell me how many edges it has. Okay, so where the faces meet, that's an edge. These are all edges. And then the vertices are the corners of the figure, so you're going to count those as well. So you're going to count the faces, the edges, and the vertices. Okay, then we've got a cylinder. It says a cylinder has 2 parallel congruent circular bases. So what's different from the prism to the cylinder is just the base. Okay, the base, and this is on the bottom as well. You can see this is going to curve, and then you can't see this part of it. But what it's sitting on is a circle. That makes it a cylinder. So this, because it has a circular top and a circular bottom, this would be considered a cylinder. A pop can is in the shape of a cylinder. Okay, it's got circular bases. Now, we don't, it's connected by a curved lateral surface. So this surface out here, we don't have any edges. Okay, it's no edges here, but this is a curved lateral surface. It says because the edges are curved circumferences of the circular bases, a cylinder has no vertices. So there's no vertices, there's no edges. Okay, that would be your cylinder. Okay, now what these two things have in common is you'll notice that they're both going pretty much straight up and down. Okay, they're going straight up, and their tops and bottoms are parallel to each other, parallel bases. Okay, the next two that we're going to go over are the pyramid and the cone. Okay, I don't know if I can get them to both fit on here, the same one, but a pyramid. Okay, here's an example of a pyramid. A pyramid comes to a point at the top. Okay, so it's going to have a base as well, and in your notes it says a pyramid has a single polygon base. So there's only one base. This would be considered the base. and it has lateral faces that are triangles. So where prisms had lateral faces that were parallelograms, pyramids have lateral faces that are triangles, and they join at the top. There's a point at the top. This is a rectangular pyramid because the base is in the form of a rectangle. Okay, this base is an 8-sided figure, okay, and it's coming to a point at the top, so it's definitely a pyramid. If there's 8 sides on the base, it's an octagonal pyramid. Okay, what I'm holding here in my hand, the base of it is a triangle, so that's a triangular pyramid. Okay, it has edges like the prism. You can see the edges. There's where those triangles or those faces come together. And it also has vertices where those points are. Those are all vertices. So the pyramids are going to have faces, edges, and vertices like the prism. Okay, and then lastly, the last type of solid figure that we're going to look at in Chapter 11 is the cone. Think of an ice cream cone. Okay, here's my cone. Like the pyramid, it comes to a point at the top, or maybe you look at it this way, it comes to a point at the bottom. But this time, the base of it is going to be circular. Okay, so a cone has a single circular base. Here's my base, and it comes to that point at the top. Okay, so it's got some things in common with the cylinder. The base is going to be a circle, but the cylinder has 2 circular bases, whereas the cone just has 1. It's going to be similar to the pyramid, and then it comes to a point at the top. Okay, it does have a vertex. Okay, but it's not going to have any edges. Okay, we would call this a lateral surface like we did with the cylinder because it curves around, but it does have 1 vertex. Okay, it says any of these figures can be right or oblique. Okay, a couple of vocabulary words for you. To be right is to be standing straight up. Okay, so this particular prism was right. It's not leaning to the side. It's going straight up and down. You've got right angles down here. Okay. You can see this is a right rectangular prism. Okay, right triangular prism. It's a prism because it's got a base at the top that's the same shape as the base at the bottom. So it makes it a prism. That base is a triangle, so it's a triangular prism, and it's standing straight up and down. Okay, the pyramid is a right pyramid as well because it's not leaning. Okay, but you can see examples here that are oblique. It's going to be oblique if that figure is leaning one way or another. So you don't have a right angle at the bottom. Okay, you think of the Leaning Tower of Pisa. It's not a right. So anything that leans in one direction or another is going to be considered oblique. That's a new word. Okay? So everything that I showed you here would have been considered a right prism or a right cylinder or a right pyramid, right cone. Nothing was leaning. I don't have any examples of something that's oblique. But you'll be able to tell. You can see that this point is obviously leaning to the left. This is leaning to the right. That would be considered oblique versus right. Okay? You've got a worksheet 11.1a that you can start on and see how you do.